Howdy, Huskies. Welcome to our 9.3. We're going to start talking about parabolas. We're going to have two videos for our parabolas on 9.3. Today is going to be basically just graphing them, getting used to some of the different pieces of our parabolas. We know we've done parabolas for a long time, but we're going to be thinking about them in a different light today. So go ahead and jump in and hit pause and try these review questions and then come on back. So, ladies and gentlemen, on this one, if you were to graph really quick our logs, pen's being streaky today, so forgive me, it kind of looks something like this. Remember, it's got to be greater than 0. So we're going to solve this, so that means factoring. So x minus 2, x plus 1 is equal to 0. So x is going to be 2, and x is going to be negative 1. So if we make a number line, we got to find out, hey, we have 3 sections. We have it when it's less than negative 1, when it's in between negative 1 and 2, and when it's greater than 2. So we got to plug in numbers. So I would try like negative 10, 0, and 10. And you're not really trying to find the number, you're just trying to find the sign. So in this case, it is positive, then it's negative, and then it's positive. So when we plug in 0 and it's negative, remember it has to be greater than 0 in this case, so that's not going to be a place that it works. So we're going to say it's from negative infinity to negative 1. Can't equal 0, so that's why it's a parentheses. And then from 2 to positive infinity. So that's our 0 for that one. For our next one, remember you can't have zeros in your denominator for your domain. So if I factor this, I'm going to get x plus 4, x plus 2. And when I solve those, I get x equals a negative 4 and x equals a negative 2. And as long as your x value, your input is not those values, then you're good. So it's all real numbers except for those. Okay, so that's generally how we write that. It really should be negative infinity to negative 4, and then negative 4 to negative 2, and then another u, and then negative 2 to infinity. That's another way to do it, but this looks a lot easier, and I think we get the gist. And since it's just review problems, we're good to go. So I put in a couple of pictures into our guided notes just to kind of make this a little bit easier so we can see what's going on. So you have some blanks here, 4 blank graphs. So go ahead and pause and fill these in. All right, welcome back. So as you can see, our equation looks a little bit different. You're used to thinking of y is equal to ax minus h squared plus k. That's the parabola that we used when we were in Algebra 2, and now is to use it in what's called our vertex form. We did that at the beginning in Unit 1 as well. Well, today we're going to be really graphing using what's called the focus. Okay, if you think of a focus as a satellite, it really sort of shows you. And so I'm going to move on down to one of the pictures I added right here. So if this is a satellite, the whole point of a focus is, if you kind of think of a satellite as it's got a little part in the middle here. So this little dot right there in pink, that's the focus. So when rays hit your parabola or your satellite dish, they are focused or directed to a central point so that all that data can be used. So that's why satellite dishes look the way they do. And that spot is very particular so that all the data can be received no matter where they get hit from that, from our satellite. So we're going to be really focusing on that focus and graphing from that focus here today. Okay, so if we look right here, these two graphs are x squareds. Now we're used to going x going up and going down, but the way we're going to write it is looking at this 4m. Some people call this a 4p value. So just so you know that if you see it in a different way, they mean the same thing. So if your m value is positive, then it's going to be going up. And if our m value is negative, then it's going to be going down. So that's what we need to remember for this first part. Okay, so our focus is going to be in a very specific spot, and I'm going to get to these in just a moment. Now, over here we have y squared. You really haven't seen a y squared parabola, but those exist too, and they go sideways. So it's the same general form, except we have our y squared being squared as opposed to our x squared being squared over there. So here it's the same sort of idea. If your m is positive, it's going to go to the right. And if your m is negative, it's going to go to the left. So one of the first things that we're really going to look for once we start graphing these is what's being squared. Is it an x squared or a y squared? And then is it a positive or a negative? So we can know the direction right off the bat. Okay. So if you go ahead and you take a look at a couple of different pieces of a graph before we start writing what those things are down. First is the focus. If we think of the focus as a center of a satellite dish receiving all our information, it is a pretty important point. So this right here is a focus. It is on that axis of symmetry. We're pretty used to that sort of terminology. But what's new is our directrix. Our directrix, as I kind of said, it directs the parabola where to go. It says, go away from me, please. And technically, it's a line perpendicular to the axis of symmetry where the distance between the focus and a point on itself is the same. So notice that this right here and this right here are the same distance using our geometry, our tick marks. And if I were to go over here, I meant to do that in a different color. Right here, the distance between the focus and a point on our parabola is the same as that line down here. So our directrix is pretty important because it's going to direct, but also we can use that to measure important pieces. Okay, so all this is going to be based on what's called an M value. So here I have that highlighted here in red to really drive it home. M is the distance between the focus and the vertex, which is also the distance from the directrix to the vertex. So that's what this lovely little diagram over here is. So again, this is not on your sheet, but it is sort of nice so we can see this. We can see that relationship. So obviously this is an x squared graph. But what we're saying is that this distance between your focus and your vertex is going to be M. And that's that same distance between your vertex and your directrix. That's also M, hence why we have the 2M here on the side. Okay? And what's important about that is if you go perpendicular to your axis of symmetry, again, 90 degrees for perpendicular, then to go over here, it's 2M to a point on and 2M to a point on. So once you know your M, you can graph this really, really easily, and we don't have to make a table or anything like that. It really becomes really beneficial. There's another thing called the lattice rectum. We're going to just call this the LR. And the lattice rectum is just the length of this, or the length in between 2 points on a parabola. So it's 2 points on a parabola through the vertex, or sorry, through the focus, excuse me. Okay, so that's just 4M. You can see it makes this nice little cool little rectangle right here. That's a good way to check your work to make sure that that rectangle does exist. Okay, alrighty, so let's go back to this and fill in the information here. So if I look specifically at this graph right here, okay, so your focus, because this is my axis of symmetry, your focus is going to be on that axis of symmetry, is going to be on the point 0, M. And then our directrix is going to be down here, somewhere down here. And notice that that's a horizontal graph, so that's y equals negative M. If we look specifically at when it's going down, again, our center is still 0, 0. So in this case, it's going to be on our axis of symmetry, which is right down here in the middle. So my focus is inside. That's important to remember. Your focus is always inside the parabola. Again, think that satellite dish. So this would be 0, negative M, and then y is equal to M. So once again, it really is all about that M part. All right, let's go over to this one. So now our focus, our axis of symmetry is going to be going sideways. So my focus is going to be inside. And so this is going to be M0. And then x equals negative M for my directrix, because it's telling it, hey, parabola, go the other way. And then if we look at the negative version, here's our axis of symmetry. So my focus has to be on that axis of symmetry inside the parabola. So this would be negative M0. And then this would be x equals M. Now, this all stipulates that your vertex is at 0, 0. as we move things around, and we've sort of seen that in these other things that we've graphed with the hyperbolas and the ellipses, these will not always stay at 0, 0. And that's what our next part is here. So here, we're going to change our equation up. Notice we have h and k. So that means our vertex has changed from 0, 0 to hk. Now, what's going to be important to note is that if we look at both of these, let's notice the patterns. X and h are always together. Y and k are always together. Okay, so regardless of which way the parabola goes, it's always going to go x and y, h and k. You with me? So my friends, remember that this is h and k, and it's always going to be change the sign, so I call that change, change. You feel me on that one? All right. So if you need to make a little reminder to yourself that the h is always with the x and the k is always with the y. Okay, always something important to remember. And then again, squared, not squared. So here's what I would kind of do is the first thing is you want to know when you're graphing these, is it x squared or y squared? That's going to be the first thing that you're going to want to make sure that you know so that you are good to go to graph these. The next thing that you're going to want to know is the direction. So I think of, okay, you know it's x squared, that's side to side. Is it left or right? Okay, so that's really looking at just what is your m value going to be. You feel me? The next thing I would do is you're going to find your center. So that would be my h and k. That's always your change to make sure you're good to go. And then last but not least, step number 4, you're going to want to find that m value again. You should have already found it, but you're going to do 4m is equal to 0 and solve. Because once you have that, then you can find the focus, you can find the directrix, and then you can find your points on your parabola. And if they ask you for your latus rectum, your LR, then you can put that down as well, okay? And I'll show you a shortcut for that in just a second. So let's take a look at this first one. Alrighty. So right off the bat, we got a y squared. So a y squared is either going to be left or right. Again, because that's a y squared, we can see that. So then let's look at my m. I just meant to use my highlighter there. So this is the 4m. Okay, the 4m is always on the non-squared side, my friends. So because this is positive, we now know that it's going to go to the right. So I now know where it's going to go, and we're good to go. So our center, so obviously we have no h and k, so we're going to go ahead and assume that that is 0, 0. So center right there. I know my parabola is going to be going that way. I like to draw an arrow. It just makes it easier to remind me that that's the direction. All right, find my m. So this 8 represents the 4m. So I'm going to say 4m is equal to 8. So my m is going to be 2. And that m is your magic number. That's going to tell you how to move around. So we know, remember, the focus is inside our parabola. So if my parabola is going this way, then my focus needs to be somewhere inside. So I'm going to go 1, 2. And I like to put an F right there to say that that's my focus. And then I'm going to go to the opposite direction, and then this is going to be my directrix. So notice I'm going from my center. I'm going to put D for directrix there. And then my points on my parabola. So those points, if we go back to this diagram here, so notice that from your focus to your point, that was 2m. So in this case, 2m is 4. So I'm going to go up 1, 2, 3, 4, down 1, 2, 3, 4. And that's going to give us our parabola. Nice and easy peasy lemon squeezy right there. Let's answer these key questions. What is the vertex? HK is 0, 0. What is the focus? So if I look at what that point is, it's all nice and labeled here. Another reason why I like to put an F or I should really put a V for my vertex right there. As I can see that that's going to be the point 2, 0. My directrix, we can see that with the D right there, it's going to be up and down. So that's x equals a -2. Alrighty, and then the length of our lattice rectum, or LR, and that's the segment, again, that passes through the focus on 2 points. That is always going to be your 4m anyways. So we already know our 4m from our equation. It says it's 8. So to go back to our picture up here, notice that lattice rectum is 4m. So just write exactly what it is right there, or do 4 times whatever your m value is. You're good to go. Okay, so we have our critical pieces. We're set to roll. So now, ladies and gentlemen, boys and girls, we're going to go to this next one here. I want you to kind of look at this really quickly, pause it, decide what the direction is. Welcome back. So we have, once again, a y squared. So it's either this way or this way. Okay, but see how this is negative? That's my 4m. So my m is going to be negative. So in this case, we're going to go to the left. All right. So we're going to go ahead and need to, now that we know our direction, put my arrow going this way so we know, I need to find my center. So this is my h, there's no h, so that's going to be 0, and this is my k, so that's going to be a -2. So 0, -2 is right there. So found my vertex. Yeah, C for center. Let's use our proper vernacular. That's thinking too many ellipses and hyperbolas. Our vertex, excuse me, center, vertex. I should change this to vertex. I apologize there, sports fans. There we go. You get what I was trying to say, hopefully. So then we're going to go ahead and find out what our p-value is. So we go again, m value. This is negative, so that's just directional. So I'm going to say 4m is equal to just the 16. So the negative just speaks to the direction. So I'm going to go ahead and say that m is going to be 4. So I go 4 to the left. 1, 2, 3, 4. That's my focus. And then I go 4 to the opposite direction. This is going to be my directrix. And then remember to find my points. I'm going to go from your focus. It's always so your points on your parabola, just so we have it down somewhere, are from your focus. So from our focus up 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alrighty, there we go. And there we go. We have our beautiful parabola. Again, that 8, because this is a 2m. And since m is 4, that's why it's 8. Cool. Let's label. So it was 0, 2 for our vertex, not the center, our vertex. Our focus, we found that as -4, -2. So we set that up all correctly. Our directrix was up and down, so that's x equals 4. Okay. And the length of our lattice rectum is 16. So remember that that's always a positive. You can't have a negative distance. So make sure that this is always positive. Okay, so even though it is 16, we got to make sure that it's positive. Alrighty, I want you to try number 3 and then come on back. Hit pause, go. Alrighty, welcome back. So we have an x squared and it's a negative. So hopefully that shows us that it's going down. Okay, so my vertex is going to go h, k, so 1, -1. All right, so now that we know that, we know the direction, I need to find my 4m, so that's just equal to 8. Remember that negative is directional, so I just take that 8. So my m is going to be 2. And now that you know that it's 2, you're good to go. So you can see that this is super fast. So we'll go 1, -1, boom, boom, boom. It is going down, so I'm going to go down 2, 1, 2. That's my focus. This is my vertex. I'm going to go up 2, 1, 2. This is my directrix. Alrighty, now over 4, because of my 2m, boom shakalaka. Easy peasy, lemon squeezy. So this is going to be 1, -1. My focus is going to be the point. Let's make sure we get that one right. It looks like 1, -3. My directrix is going to be y equals, because it's going side to side, so that's y equals +1. And then my LR is 8. Remember, it's not a -8 because it's positive. So that is our first video on parabolas, and we're going to pause there to make sure we are all good on graphing, making sure we can find those m values. And it really comes back to this diagram. So hopefully this is one that you can go ahead and pause, write down, make sure that you guys are good to go, because this is really helpful in constructing this. So circle this bad boy. But remember, it really is all about that focus, that satellite dish that really solidified that example for us. And then our directrix. So I know that these diagrams weren't part of your guided notes, but hopefully they show a little bit more about why we're doing what we're doing, and it's not just random stuff for you. So this is Mr. Naughton saying we'll see you next time.